so everybody can take a look at it later if they want to. I'm gonna close. Let's see, close these. I have these open. Looking at some of your all submissions for the first project. And I'm going to download the part on the practice quiz. So I got to start this. Be a true test here since I'm on the clock now. So I'm going to download the zip file. Really important whenever you're doing all these, you got to unpack the zip file. I see that mistake being made a lot. We're just trying to open things out of the zip, and that causes issues. In this case, it's saying that the assembly consists of one curve, one head, 4 links, and 1 tail. The curve origin axis should be aligned with the origin axis and it should be fixed. So I know I'm making an assembly. Probably it's helpful to read the whole problem before you get too far in on any of these. I want to have the curve as the base for this. And I want to click on the green check mark. Again, that green check mark is going to make the origin of the curve align with the origin of the assembly, and all the reference planes and axes will be lined up as well. So the top and the top are on top of each other, and you see that. Now, the curve has a curve in it, but right now we can't see that because the way my current view settings are. Not all of you may have the same view settings to start off with, but I need to turn curves on to be able to see that geometry and to be able to use it. Now, I can also select it out of the model tree, so I don't need to be able to see it to select it, but being able to see it helps, to say the least. And again, I'm looking at this quiz question. I'm going to check and see what they actually want me to make. Again, I have the other parts in here. I want the mouth of the snake to be 20% of the distance along the path from the origin. So that's telling me I'm going to use some path mate. I want the spacing on the tabs to be equal. So I'm either going to be using some kind of symmetric or tab width mate. I want concentric holes. So obviously the concentric make there, and then in 4 points that are coincident based off the drawing in the second part here. And my arrows are not super clear. And I want to figure out what the center of mass of the assembly in the X direction is in millimeters. And really, it only matters for me to set my unit system. So I've got the right unit system. I've got these parts in here. I'm going to go and load in the head because it seems like that seems to be what's going to define the position of the rest of the parts. And I think one of the things that can be important about doing this is when you have parts that have a lot of motion, trying to get all of the parts sufficiently defined as you're going through it can help save you a lot of headache. So I'm going to go to my downloads folder. I'm going to start with the head of the snake. And I actually wanted to get this as well defined as I can right off the bat. I know there's a point here on the mouth of the head of the snake that I want to put coincident on this path. So I'm going to go into my mates tool. I'm going to use the path mate under advanced. And then the path is this selection here. And I'm going to use a percentage along path of 20%. And that's going to give me 20% from that origin. So that's the starting point. I've positioned this kind of appropriately. Now, I don't have a position here, how this wants to align, but I do want to get it kind of close to where I want it at the end. Again, if I have that farther away, it's going to be more likely to flip around on me, and I want to try and avoid those flips. Next thing I'm going to add is my first link. And again, I'm going to try and add these one at a time and try and define them as good as I can when I add them into the part. So that way I'm not having to do, worrying about the thing collapsing as I'm adding more and more components. So I'm going to bring in one link. And I'm going to add the mates for just that link before I go on to the next part. So I'm going to use the mate tool. I know I want even widths on this tab. So I'm just going to use the width mate. Now you could also use the coincidence between the center planes of these two objects, would work just as well, or symmetric about the plane. The tab width just makes sense to me. So I'm going to click on both sides of the tab and both sides of the inner side portion. It doesn't matter which order I do these in. So it doesn't matter which one is the tab and which one is the width. I'll accept that mate. And then I'm going to add another one for the concentric. So I'm going to click on this hole and this hole. I'm going to make those concentrics. I'm going to go back to my standard mates, click on concentric. I like that, so I'll accept that. And then I'm going to go back to my options here. It looks like I should have a point on this tab in the middle of it. Yeah, I have a point down here. I think that may have been my fault. I may have used the wrong sketch on there, but I think I'll add a point to that link, so I know that I have it. I could also add it to the head, I suppose. So I'm going to sketch on the right plane. I'm just going to add a point at the center of the part. Normally you wouldn't. Sometimes you do have to modify parts inside CSWP, although that was not actually my intention for this quiz. But I do want that point to be concentric with this line because it's listed in my list here. So I'm going to use that to add a concentric mate to, or sorry, not a coincident mate between that point and the path. Now you may ask, well, how come I didn't use the path mate again? You don't want to use the path mate more than once because all these different points are going to have a different percentage of distance along the path. If I try to add the same path mate, it's going to cause it issues. So I'll accept that. Now that I've got those three mates set up, I don't want to have to add the part and the mates again. So I'm going to use the copy with mates tool. So I'm going to right click on this part. I'm going to copy with mates. Click on the next button. And again, this is very confusing because most of the things you can click on the green check mark. No, this one we have to go to the next. And then I'm going to use my width. So this is going to be the width side. This is going to be the width side. Then my concentric. It's going to be concentric with this hole here. And then on this one, I do have a point on this far side that I could make coincident on this piece, but that's not the meat it's looking for. It's still looking for the center hole there. You can see the line is selected. So I'm just going to skip that mate. Click on the green check mark. You can say, okay, well, I want to do it again. Okay, I'm going to do it again. I'm going to do this side, and then the hole. And then on this one, I do want to add the coincident mate. So I'm going to click on coincident, and I'm going to click on the line. And then I'm going to click on the green check mark, and just repeat this process. I'm doing this 3 times because I started with 1 part, but I want to go to 4. And what I'm doing is I'm skipping the mate that I don't want just by not making that selection. So I'll accept that. Check mark. And once you're done, you can click on the exit, the X to exit. And on here, I want to try and get that point onto this line. So I'm going to get kind of close. Click on that point, click on my line, add my mate to make them concentric. I can note that this one is still underdefined. So if I grab this head, I can still spin it. But I'm expecting that when I add my tail to this and put the tail along the line, that's going to add even more constraint onto it. So let's go to the downloads folder, which apparently I have opened several times. Pull in the tail. Try to pull in the tail. Wait for SOLIDWORKS to respond. When in doubt, just wait a second. I want to make sure I don't have 2 tails pulled in, and I do have 4 links. Okay, 1, 2, 3, 4, so that's good. And I'm going to add the mates to the tail, which are pretty similar to what I did before. So I'm going to go to Advanced, Tab, or Width Mate. Click on both sides of the width. Click on both sides of the tab. Go with that, accept it. Go to Standard, make the concentric mate. Points here. Like that. I'm going to move this tail closer to where I want it to be. Again, I don't want to add that path mate until I've got it somewhere close to the right position because I don't want it to flip and end up kind of somewhere over here. So get it as close as you can before you actually make the selection. And then once you're close enough, you should be able to click on those two and accept it. If it doesn't give you the one you want, you can always just back out or click on the undo button and not add that extra mate. And that actually fully defines the assembly. Most of the time, if you're asked for the center of mass of an assembly, the assembly really needs to be fully defined. There are exceptions to that. They can ask you for an assembly with a specific condition, like a collision or something else, based off of how you set it up. So you can have things that are underdefined, but then become defined based off of how you have them set. So watch out for those kinds of things. But this one is fully defined, so I'm pretty confident this is going to be okay. I'm going to evaluate mass properties. I've got a center of mass position in the X of 83.61, which doesn't sound right to me, but I'm hoping it is. Origin meets, should be right. Let's just do it. Base properties. 83.61. Copy. Okay. No, this is I got it wrong. I'm going to go to the isometric view inside here. Show me my view cube here. X direction. Oh, I uploaded the wrong curve file. I think what I did on this is this curve here should actually be a lot longer with a sweepier path. I made that second one to make it easier for it to kind of solve. And I think I uploaded the wrong, when I zipped it, I probably didn't save before I zipped it. I'll fix that later. If you guys put in 83.6, I'll give you credit for it, but I want to fix the actual file I uploaded so it's a little easier for you to work with. But that's how you would do that.
Dr. Laura, but
Yeah.
what's the difference that you say about making it part by part or doing the whole thing all the way first?
So if I had gone through and put all these parts in and say the easiest thing to do is to do like the width and the concentric mates. So if I had something like this is really difficult to manage because it wants to move in all kinds of crazy ways. So if I make it like that, and then I add the mates like in different directions. So say I add the mates, the coincident mates from the tail forward. Coincident between the path and that point. Watch, it'll work now. Say I do the middle point and the path. And then this point and the path. That worked fine that time. But a lot of times what will happen is you'll end up getting parts that are, they go like this, where they collapse on themselves. And then fixing that can be a lot more difficult than making the assembly in the first place. And so the advantage of doing it kind of part by part is that you can kind of make sure that each part as it comes in is in the close to the correct position as you're going through. And then you don't get those situations where the configuration of the assembly is just way off and you're trying to figure out how to fix it. So it's just trying to avoid putting yourself in a situation where, the geometry is not what you want it to be. Does that answer your question, Marza?
Yes, thank you so much.
We're trying to avoid stuff like this, where it just turns into like a garbled mess. Because it will do that if you just add the mates in without trying to position the parts kind of appropriately. Also, using that copy with mates feature saves a lot of time because I don't have to make both the selections. I can just do just the selections on kind of the distal end. So whenever you have repeating parts in an assembly that need to be mated in a specific way, then that can be very helpful. I think it was Caitlin was working on a pendulum assembly, like a Newton's cradle thing, where there's a bunch of different parallel mechanisms. You know, very easy to do that with the copy with mates tool. So kind of the path mate, the copy with mates, and some general practices is the goal of this exercise. I'm going to stop recording.